left off. We were talking about, look, we talked about like the logic of like true, false, ands, ors, not, and we also talked about like those are the Boolean operators. We also talked about the comparison operators. Those are operators where you might compare two integers, but you get a Boolean back. So now we're going to make use of these things, okay? So, oh, you can't see anything. That's better. So, you know, sometimes we have a choice to make. Effectively, all of our code so far has been very linear, where you start here, you do the next thing, next thing, next thing, next thing, next thing, and the flow goes like this. But every once in a while, you might get to a position where, well, you've got a question. And depending on the answer to that question, you might have to do this, or maybe you have to go do this. And then maybe it continues down here, or maybe it carries on a whole other way, I don't know. But as of now, we have no way to kind of control that type of flow. But we're going to learn it now. We've seen Booleans, and Booleans can be used for a lot more. So look, we can check if a number is positive pretty easily. Is a number, assuming the variable a number contains a number, and I want to see, okay, is it greater than 0? Which is another way to say, is it positive, or is it not negative or 0, I guess. So is it a positive number? If a number is greater than 0, that'll be true. Then we can make use of this if statement. I'm just going to copy this code. Whoop. Paste it here. I'm going to get rid of the docstring for visibility. Run. So all of the asserts pass. So what does this code say? Well, what does it say? Smush a number. It should be a float. It's going to return a float. I'm going to start with this variable called return value. It's equal to a number. Now, if a number is greater than 0, if this expression evaluates to true, the if statement wants to check whatever comes after it on that line, is it true or not? If it's true, everything indented will run. If it's not true, it skips. So I'm going to draw this real quick. We basically start with some instruction. Then we say if that negative thing, okay? If it's true, we're going to go over here, do something, then go back here, and then like return a value. If it's not true, so like true, otherwise, we just don't do that, okay? We're going to do this extra step if the condition is true. Otherwise, just ignore it, okay? Let me draw like there, a circle. Maybe it makes it a little nicer. Okay? That's the idea of the flow here. So let's run some examples, like if I put in a 5. Number 1, I need you to work with me on this. Smush a number. When I call smush with 10, what value does a number take? Say it with vigor.
10.
Wonderful. So return value becomes what?
10.
Then I say, hey, a number, are you greater than 0?
Yes.
Who said yes? Try again.
True.
Very good. A number greater than 0? True. So if true, it evaluated a true. So that means we go in here and we say, okay, return value, you're actually going to be equal to a number, which is what?
10.
Divided by 2, which is what?
5.
So return value becomes what?
5.
Vigor.
5.
5. Then we go here, and what do we return? Return value, which is 5. So, yeah, we better get 5 back. And look, it passed, so we're happy. What happens if I put in negative 10? All right, a number is what? Vigor. There you go. I need gumption. You know, I need all those good positive words here. So return value becomes what? A number greater than 0. False, because negative 10 is not greater than 0, so false. We skip this entirely, so we just jump down to here. We return value, which is negative 10. Negative 10. So do you see how this allows us to control some flow? It allows us some choice in our code. We never were able to make a decision, easily at least, without the if. The if does not need an expression. It needs ultimately a Boolean. Whatever's next to if it ultimately evaluates to true, it could be the literal true. It'll always run. I could put if false. That'll never run. But as long as this evaluates to a Boolean, it's going to work just fine. I mean, like, it won't crash. Now, maybe it won't work the way you wanted it to, but it won't crash at least. And let me show you a quick thing, right? So like if I say like if true, every time I run this code, I mean this is a silly if statement, okay? If true, if you ever have if true, true is always true. It's never going to not be true. So if true will always run, meaning there's no need to put it in an if statement, right? Every time I hit run, it's always going to run that code. It's never possible for true not to be true. This is also useless because the code inside the if statement could never possibly run. It's always false. So usually you're going to see expressions there, but the point is the expression is always going to evaluate to some Boolean value. That'll be true, false. Any questions about the idea here? It's pretty nice. What I like about this is I personally find it rather intuitive in terms of like saying, if this, do that. Otherwise, just don't do it, right? Like there's like it like follows English pretty reasonably well, like how we would think. So there's like an intuition behind this, which is really nice. Okay, yeah. This is just what we just did. Great, awesome. So here, real quick. Activity time. Write a function is negative that returns true if a number is negative, false otherwise. So go have some fun. I'll give you 3 minutes to do that, and then we'll talk about it. Yes, be very careful with indents. And one thing, if you haven't already, change the default indent of Colab to be 4 spaces, not 2. 4 is a lot easier to see. Bless you. That was a good one. Oh my gosh. By the way, you could do this one entirely without using an if. So if you want to get fancy, you could try to do it without an if. It's actually really easy to do without an if, but it might not be immediately obvious. Raise your hand if you're done. Raise your hand if you'll be done in like 1 minute. Okay, keep going, keep going. Did you do it without an if statement? Yeah. You did? See, isn't it like, obviously? Now, that's kind of not the point of the activity, but still interesting nonetheless. All right, let's talk about it. So, first of all, there's actually a lot of ways to do this. In fact, there's literally an infinite number of ways to do this, but let's talk about one. One could be this. If a number is less than 0, it is therefore what? Negative, right? So if that's the case, return true, okay? So let's look at this code in the context of what we see here. All right? Actually, no, we'll come back to this in a second. Now, how could I return false? Well, there are a couple of ways to do this. One is to remember what we learned about return. Whenever your code hits a return within a function, the function immediately stops. No other line of code in the function will run. So if your code goes and it says, okay, if a number is that, return true, it's done. I don't care what's after it. It's not going to run. Now, what's interesting here is, if we go up here, we saw that this code works like this, right? Check something. If it's true, do this extra step, then carry on immediately after. If it's not true, just skip that step and just go there, right? Meaning, after this line of code runs, this would be the line of code that runs. But if this is not run, we just skip to go to there, right? But what's interesting here is I've got a return here, meaning whatever I have after can never be run. Meaning I could do this. All right? Now you might say, well, I mean, how is that possible? Because after the if statement, it should run this line of code, but there's a return, so it immediately stops, meaning if we ever hit this line, it'll never get to here. We're just kind of taking advantage of the flow and use of how returns work. If this makes perfect sense to you, great. If not, it's fine. It'll come with practice. Effectively, what we've done is we've asked the question. If it's true, we return, and the function's done. It will never return back to the main flow. It kind of wants to, but because there's the return, it stops, and it could never carry on. So we effectively have that situation. Okay? Who here did it with something like that? Okay, entirely fine, makes perfect sense. This works because as soon as we hit the return, the function's done. We will not run that line of code. Let me be a little bit more even clearer. I put in negative 1, 2, 3. Negative 1, 2, 3 is less than 0. Return true. We're done. I put in positive 1, 2, 3. Positive 1, 2, 3 is not greater than less than 0. So we skip this line and go here. We're done. This would be like the true. This would be the other. Great. So again, raise your hand really quickly if this is how you did it. All right. Who did it this way? Did anyone do it like that? No one? Well, that's fine. There's nothing wrong with doing it the other way versus this way. In fact, some people would argue this is a better way because it's not good to have an ability to have your function like exit at two different areas. I don't prescribe to that mentality, but some people would make that argument. But the flow of this is going to be more like this, where it does actually come back to the same line, which is the return line. Okay? Now, did anyone look ahead, or maybe they had some experience before, and write it like this? Oops. Who wrote it like this? Okay. So for those of you that it's like, what? What's this else? We're going to look at it in like 3 minutes. But else is sometimes you've got code that doesn't go like this, but you want it to go more like this, where you have a decision and you're going to do one thing or the other. Not this or maybe not this. It's going to be, no, you got to do either this or this, and then you return. Or return might not be the right word, but carry on with the same flow. I mean this, where you must do one of two things, and then you come back to this like main flow together. That's what this like if else does. Else means like, okay, if this was true, okay, if this is true, don't do that. If this is false, do that, right? Only one of these two things will ever run. They're mutually exclusive. In fact, you could have big chains of these, which we'll see shortly. And then finally, who did it like this? Okay, before I show it to you, let's look at the flow of this. If this evaluates to true, we return true. If this evaluates to false, we return false, right? So it feels like if true, return true, if false, return false. Couldn't you just say like, that? Is that what you did? No, well, you did it a different way. Interesting. Because this will also work. Why? Look, if this evaluates to true, if this evaluates to true, what will this return? True. If it evaluates to false, what does it return? It's the same logic, just without an if statement. Now, you might look at that and be like, oh, that's better. Well, okay, look. In general, it is a bit of like a meme in computer science when like new programmers do like if true, return true, else return false. Like it's a bit of a joke to do what I showed you a moment ago when this would work just fine. Except if it helps with like readability and comprehension of the semantics of what the code is, or the semantics of what the code is doing. That's a fancy way of saying when you look at this, this code is really obvious what its purpose is, where the other one might not be as obvious. So if you can make an argument that like, okay, it makes your code more obvious, then good. Just FYI. All of those versions we just looked at are equally valid. They're all fine. If you had one that you saw that you liked, awesome. If you had one that you particularly disliked, cool. It doesn't, whatever you're happy with, go for it. It's all going to work just fine. You might say that, well, then what's the point? Well, they all do have their own purpose. For this particular problem, these different variations of like how the flow could go were all workable into what we wanted to do. But sometimes you really do have a like, no, it's got to be one or the other. Or do this, or otherwise just skip that step entirely. Or like whatever, it doesn't matter, we're ending early, it doesn't matter, right? They all have their own place, okay? All right. Yeah, cool. Did we not just, oh, yeah. All right, compounding conditions. Just like you can have these long compound Boolean expressions, just like you can have long compounded algebraic expressions, you could throw those expressions into an if statement just like this, right? Now what does this check? Well, who here remembers what this is? Mod? It gives you, effectively it gives you like the remainder, right? So if I do like a divided by 3, but this gives you back the remainder, not like how many times can you divide a by 3. Let me just remind you, right? If I have like 1, 2, 3 divided by 5, the answer is 24.6. There's some left over, right? We could do integer division to ignore that. That's 24, but again, there's some left over. What's the leftover? You can get that with mod. 3 left over, okay? So what this means is divide 123 by 5, but tell me what's left, okay? When you look at this code, so like, what does this mean? Well, we could read the doc string, but really what this is saying is if you can divide a number by 3 and you're left with 0, that means that number is evenly divisible by 3, right? If you divide something with remainder 0, it's evenly divisible by that value, correct? Correct. And here, same thing but with 5. If you can mod a number by 5 and you're left over with 0, then that number is evenly divisible by 5. So what is this checking? It's checking if a number is evenly divisible by 3 and by 5. So this will tell us, do we have a number evenly divisible by 3 or 5? Sorry, 3 and 5. Pretty neat. You can do compounding expressions. Expression, look, we've got an arithmetic one with a comparison and a Boolean. There's a lot going on there, but at the same time, yes, there's a lot going on there, but this code is still pretty reasonably clear, I think, if you know what like mod's doing, right? Any questions about what we see here? Now this example takes this strategy. If it's true, set return it is, and then we're done. We're never going to return the flow. If it's not true, we just jump down here, will we return nope. Cool. We could rewrite this to work more like this, or even maybe kind of like this if we really wanted. It is all workable, just we have a choice based on how we like to code it. Happy, sad? Okay. And here's some tests. Great. Right, like 0 is evenly divisible by 3 and 5, 15, negative 30, and then we've got some other cases here. Neither, 1, not the other, you know, it's all I'm doing. Cool? I think that's pretty neat. Okay, yeah, okay, no, mod, it's often called mod. It effectively does return, it does division, but gives you the remainder. Another really common use of mod, by the way, is to check if a number is even and odd. How do you do that? Well, check if a number is evenly divisible by 2, right? If a number is evenly divisible by 2, it's even. 123 is not evenly divisible by 2. How do I know? Well, 1, I know, but 2, I did the mod, and I got a 1. It's odd. 4 is a 0. That means it was evenly divisible. It's even. 5, we got a 1. 0, right? And now you might say, well, how come you can't get another remainder? Well, you can't get remainder 2 when dividing by 2, because if you had a remainder 2, you could still do one more like division step, right? So whenever you do mod, the values you get back will only ever be 0 through this value, but excluding that value. Like I could do mod 100, I could only ever have a remainder of 0 through 99. Because if I had a remainder of 100, well, I could have actually taken one more 100 out of like the numerator, right? Anyways, this is just going over that. Great, cool. Now, okay, this is what I was talking about, the if and else. This is a very common pattern. If x is greater than 10, do something. Do something is just some stand-in function. Who cares what it is? Doesn't matter, but we're going to go do one thing. If not x greater than 10, do something else. So this is a mutually exclusive thing. You're either going to do this thing or that thing, okay? Now, this pattern is so common that we've replaced it with else. Else means just do the not of whatever that condition was. That's all it does. I think else even has a nicer like flow. This would be like an example of, maybe you could argue it's not an example of it, but I'll use it as an example of it anyways. This is an example of what programmers call syntactic sugar, which is a funny phrase, but what that means is we've made the syntax just kind of nice, right? We could say this is like your default thing, but people came along and said like, well, no, we like this keyword else that means that. It means the same thing, but it's just a little bit nicer syntax. And we call that syntactic sugar. It's sweet, I don't know. The two examples above will effectively do the same thing, but you know, the second one's nicer. You write less, that's a big win. I feel like it's easier to understand. Like I don't need to like mentally parse, wait, what is not x greater than 10, you know? And it's also like, it eliminates potential bugs. Because like imagine I change this but don't change that, and then suddenly this ain't gonna like, but I should have, suddenly it's not gonna work right. Where this, I don't need to worry, like if I change that, I implicitly change that. Cool? All right, here is another one, right? Write a function, another activity. I'll give you 4 minutes for this one. Write a function called hail that takes an integer as an argument. If it's even, hint, use that mod. If it's even, return the value of that integer divided by 2. If it's odd, return the value multiplied by 3 with 1 added. In other words, given a number n, return n divided by 2 if it's even, and 3n plus 1 when it's odd. Okay? Take 3-4 minutes to do this one and see what happens. Oh, let me just go here. Raise your hand if you're done. Raise your hand if you'll be done in like 2 minutes. No, in 1 minute, 1 minute. I'll give you one more minute. Yeah? Okay, have at it. Ooh, which one do you got here? I can't see. What is that? You've got the raised seams at least. It's a nice one.
I got it from like a baseball guy. I don't know which one it was, but it was like a random.
This is probably 65 cc. It's a good one. Yeah. All right, so what am I going to do? Okay, if n mod 2 is 0, it's even, right? And if it's even, I can return n divided by 2. Whoops. Right? Else, return n times 3 plus 1. And because I'm always paranoid about order of operations, let's just do like that. All right, and you know what? I kind of like doing like this. There. And that, I think that'll work. Who here did it something like that? Close enough, at least. So this would be an example of kind of like, I didn't show that one before. I did the mutually, can you see this back there? I did like the mutually exclusive thing where it's like if else. But because I've got the returns in both, we'll end early either way. Doesn't really matter. That means really I could have done like this without the else to do it more like that. Because if it's even, return, stop. And then if it's not even, we're going to have to do that other thing anyways. So again, this is all about the flexibility the code gives us. There's a billion ways to solve these problems. And I'm just using variations in syntax. If you don't like either of these, like if you prefer, let's do that. You could do something like, I don't know, classic. You dropped your baseball. Like maybe something like this, where now you will return flow and return from one point. Why would you do it this way? Well, again, some people really don't like having like more than one return in their functions. Some people really like having one, so you always know where it would stop in code. Entirely reasonable to like it that way. I'm not one that says you have to do it that way. It's a choice, that's all. Any questions about this one? Raise your hand if you didn't get this one. Be honest. Okay, what was it about it? Like having seen a solution, what was it about it that was like, ah, yes, yeah, that thing. Like what tripped you up?
I kept trying to like put true and false
Into the, okay, classic. Don't force it. It's just about the expression, it'll evaluate to a true or false. Yeah. Anyone else had trouble with it and want to share what it was? It's good to share. Okie dokie. Awesome. All right. So now, again, we already talked about the different smushes. If I go up here, we saw a smush like this, right? Where I didn't make use of an else. I go down here, and I show an example of a smush with an else. It's all, if you're at this stage saying, which version should I use? It wouldn't have mattered. You could have made it work. You'd have to change a couple other things, but at the end of the day, you could make it work any of these ways. That's not always going to be the case with conditions, but you do have the flexibility in a lot of cases. And just do whatever one you're happy with. It's going to be just fine. And yeah, here's another one where we've got like the early returns. Great. Then sometimes we have something like this. All right? And we have to be careful with something like this. Okay? And let me show you what I mean. Look at this code. I'm gonna warn you, it ain't gonna work. Okay? Here. Can you see that reasonably well? Okay. Look at this code and first of all, try to figure out what it's trying to do. And then second of all, see if you can figure out, like I'm warning you right now. Okay, actually first, I'm going to give you 30 seconds. Look at this code. Try to figure out what is the goal of this code. Hint, it's not correct, but what is it trying to do? Don't get too focused on finding why it's not correct right now. Focus on what is it trying to do. Take 30 seconds, figure that out. Okay, so if it wasn't obvious, what it's trying to do is take like your percent grade and give you back like a letter grade. So, you know, if you got above 90, 90 or above, it's A plus. You know, 80 to 90, A, B, C, and so on. And there I throw in the number 5. Well, that would be a fail, right? And so it seems to be working just fine. Let's do like 55. D seems to be working just fine. Let's say like 95. D. Okay, that's clearly not correct. Now, first of all, it's doing exactly what the code says. The code is operating exactly how it should be given how it's written. But the key problem here, you know what, take another 30 seconds. If you know what it is, great. Keep your mouth shut. Take another 30 seconds. Don't raise your hand once you found it. Don't spell out the answer when you found it. Just think about it, lock it in, and then we'll talk about it. So take 30 seconds and try to figure out what's wrong here. And there's one trick to finding it. What does the code say? And maybe think about it in terms of what we talked about here. Here's what we wanted to happen. We wanted to make a decision, and then based on it, we're going to do one of these things. It's either going to be an A plus, an A, a B, a C, and so on. That's what we wanted. But that's not what that code says. Each if statement is entirely independent of the last. What this does is it goes, okay, is it greater than 90? If it is, great. Then we ask another question. Oh, okay, so is it greater than or equal to 80? And then we carry on. Basically, what does the code say? if I put in 90, let's say I put in 95, letter grade is 0. Is 95 greater than or equal to 90? True. Letter grade becomes A+. Okay. Oh, okay. Is a 95 greater than or equal to 80? Yeah. Okay, letter grade is now actually A. Is it greater than or equal to 70? Yeah. Now, why didn't it go to F? Well, actually, the last two become mutually exclusive because there's an if and then an else. So only one of these two will run. But all of these run independently. There are a lot of ways to fix this. We could just put a return here instead. Get rid of this, do the return, do the quick returns, and then we will never execute any of the following if statements because it's done. That'll fix it, right? We could say, like, if letter grade is greater than or equal to 90, or, well, let's do this one. If percent grade is greater than or equal to 90 or 80, but less than 90, right? I could say, and percent grade is less than 90. Like, let me show you. And percent grade is less than 90, right? So I can actually explicitly bound it. That could fix it too. And another way, though, is to do this. You turn them into elifs, which means else if. This means they're actually now part of the same question. They become mutually exclusive. Only one of these can run. If this ran, we're not going to run this one. So this should fix it. So there's a lot of ways to fix it. What have we got? For the sake of, yeah, there we go. So there you go. There's a lot of ways to fix this one. Is one better than the other? Not really. They've just got choices. We could sit down and argue, well, elif is good because it's about the intention, only one should, yeah, sure, fine, fair enough. Like, we can make these arguments, but at the end of the day, they're all basically the same, just slightly different syntax with the same semantics. The syntax is what the code is. The semantics is like, well, what's it supposed, like, what's it doing? Yeah, okay, this is just explaining it. Great. So elifs could fix it. Great. Cool. Yeah. Okay, let's do an activity. Write the function. Here. Here's the activity. Where's the one I want? No. I want you, here, this one. Write me that function. Just write me the function. Also, by the way, I have never seen worse writing in my life than I saw last time. Do better. Another thing too, when I say put your name on it, don't put, my name's Jay. There's like 30 people whose names start with J in here, okay? Write out your full name. I'm Owen. There's like 3 Owens. So put your full name. It has to be in. When that turns to 1221, I ain't taking it anymore. Hand it in right here, and this time style points count. If the pile is all mishmash, you all lose.